Good afternoon, not morning anymore. I have the pleasant and challenging task to keep you awake after the lunch. So I'm going to do my best to be able to do that. Usually I am an evangelist of artificial intelligence-based solutions. I myself had a startup that was building an AI-based knowledge management software. But now I am rather focusing on the very basics of digitalization, so that the parts that I meet as a consultant on a daily basis, that how do C-level executives of medium and bigger level firms receive the message that yes, we should do digitalization. And this is the key message that I wanted to get across, that building a strong data supply, but based on an internal data demand. There are a lot of companies, when I first go there and ask them that, okay, how are you doing with the digitalization? And they start to tell me stories about how they have the ERP system and how it is automated and what kind of reports they have, and a lot of cool stuff, and even forecasts based on their previous customer surveys and customer data. But then as we go into more detail into the conversation, they tend to say that, but amongst ourselves, most of our data is on paper. And that's really what we're starting from. And that's what I see in most of the cases, that they have a lot of systems, but the tradition is that we have some things in paper and some things in Excel. And of course, we have an ERP, and we have different levels of complexity and recommender systems and big data. They have a lot of data, but at the end of the day, it's intuition, how they drive the business. Can anyone recall the 3B concept of the morning presenter? What was the 3B concept? Yes. Belgian beer-based. I love that. It's a really good term. I tend to call that intuition-based decision-making, and it has a huge track record of working well. And actually, that is the thing compared to which we have to compete when we want to implement some kind of data-driven solution. I'd like to have one question, that how many of the audience is in consulting? Yes, quite a few. Yes. How many of you are in digital transformation kind of consulting? Helping digitalization, yes. Again, quite a few. Yeah. I think that my presentation is mostly for them, that how do we see the practical level of digitalization that is not far above, but how do we start off? Usually this is what I see. There's a manager, oh yes, this is not working here. There's a manager up here, and there are a lot of people and machinery somewhere down on the floor, and people have an idea about where they should go, and sometimes they see reports. Usually the first thing that they think of is they should have a data collection layer. They should know more about the data. Well, sorry, about the production, about the sales team, about a lot of things. But of course, that doesn't really change anything. I saw a lot of companies who had a lot of data but didn't make use of it. They also have to have some kind of a data processing or integration and transforming layer, which is usually an ERP system. That also helps a lot and automates a lot, but practically it is still not useful regardless of the automation. But the real issue is when we go to data-driven decision-making. And that's the real difference between intuition-based and data-driven decision-making. And what I see is that practically this is how it looks like, that they have a huge chunk of manually collected data. There are a lot of data that is collected by machines. Some of that data is processed. which is a little bit focused on the things that we collect by hand or in Excels because we understand those at least. And then some of the data we use of that. What they usually see as a progress of digitalization is that first, extended collection of data with current machinery, that, okay, I know that what I can collect, so let's not do it by hand or in Excel or something like that. And I have a lot more to be collected. Usually this is the first thing that people think of when they think of Internet of Things and Industry 4.0, that yes, I have to have a lot of data. But then I have to have a lot of data that I can process, and especially I have to have a lot of data that can be used. And the idea would be that we need levers for decision making, and we have to start from the top down instead of the bottom up in cases of implementing something like this. What I brought to you today is a case study of a company, a middle company in manufacturing, where we've been invited after that they rejected a thorough implementation of an MES and ERP and a full system that they refused to go with because it was too much of an investment and they didn't understand what the concept was. So yeah, about the levers, it's usually, most of you might have seen this term, the overall equipment effectiveness, that how many did we created compared to how much could we have done. This is the usual measurement, and this is data. That the difference between how much we measure and and how much we could have done. But it can be broken down to availability. How much do I have my machineries going? Performance, how fast are they going to the maximum level? And the quality, how much waste do I do? And that can also be broken down into these can be collected with data, and the causes can be also collected. People do this, but they don't use it as a data source. And based on these data, we can create an action list and interventions. And the loop is the important thing. That how do I create a loop that supports a specific decision-making process? In this case, increasing the level of overall equipment effectiveness. And what I see on a practical level, that every morning they go in and they take a look at the numbers of yesterday, of how high was yesterday's OEE. It was 67. It's a little too low. Now it was 78. Oh, that's better. But it doesn't consist of actions. We have to boil down the data that can help us to do actions. So this is the overall plant floor. You can see that there's a press, there's steel coming in, they press it to a certain shape, they create the paint, they paint the material, and they burn it. So that's the key thing. And as you can see, these things are where they collect the data with paper. And these are sensors that they have implemented already. When I went there, oh, we have SCADA, we have all the sensors, we have PLC, we do everything. But on the other hand, they also had a lot of Excel sheets and a lot of manually collected data. So what we had to do is to break this down into steps of digitalization so that every step would gain some benefit for them. So the first step was a very simple one, that if they have this PLC that collects all the data, let's just create a link between the Excel sheets where they collect all the OEE and not write it down manually on a paper. It sounds so dumb, but the first level of digitalization is always to generate the data layer that you can build upon based on something that they can understand. How is it going to help them? It's going to be a lot less manual work for the people who they want to help with the whole process. Then the next thing was that we implemented a data collection system that reaches out to all the PLCs and gathers the data and can create the combination of the different data and can analyze them and give a little report, a web-based report. Also, we had to create that they don't just write down that, okay, the machine stopped for 10 minutes, but what are the causes of those breakdowns? So we had to create this list of why things are breaking down. Again, just the practicalities of how things are working. And the result, what they want to achieve with that, is that they want to know what are the key OEE drivers, that what they can act upon and how they can improve the whole process. So it's about creating the loop of how they can use the data. It's about how they, instead of just relying on the instincts of the floor manager, then how can you use the data? The next thing that, okay, now we can implement the quality material, the qualities of the materials that are coming in, so that when they adjust the different machinery, they can adjust it based on the different qualities of the materials. Based on that, before that, they just adjusted it the same time every time. And they spent a lot of time readjusting is not good enough, it's not good for quality, da 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 da. If you can combine the input material qualities with the adjustment criteria, and then you can have an algorithm for that. Actually, that's a machine learning based algorithm, but that already helps to reduce the downtime of changing between the different products. So again, the focus is on the faster change time, that how can you help them to fasten the pace of changing between the different products. Again, we could reduce some of the Excels and manual inputs. And then we also implemented how to involve to use the quality of the different products, so that they always measure the quality that is coming out of the paint, and they only use it for when there's a complaint, then they use it for complaint management and what was in that. Did we notice anything wrong back then, which is technically useless. But if we directly insert the quality data of the outcoming product to the person who is managing the PLC, then the system, a data, can tell you if, oh, there is going to be a waste because it is going towards the end of the approval ratio of the product. So that's called statistical SPC, so it's statistical process control. So that so it comes from the practical areas of how I gather the information and how I channel them into the places where this can be used. And the final one, that we eliminated most of the things, and there was a visual control, or the things are coming out from the machinery, and then someone was checking if this was good or not. And if they said that it's not good, then they try to take it out as fast as possible. And so they can implement a camera that is constantly checking the quality of that material and highlighting the mistakes that that specific product might have, which can be compared to the complaint handling costs that they already track. So the key message that I wanted to get across, that they had the idea of digitalization. They had very specific tools of SCADA and GE Historian, and they bought licenses, and they had a lot of tools. They had a lot of sensors, but they didn't use it. Why? Because they didn't know how to implement it into a meeting that, okay, what do I want to use the data for and how do I apply that data? And if we break down the process of applying more and more data, then it really helps them to roll out. And this is the end message, that we have to have all these three things to be able to start a project. And I guess you won't see it from the background I said there. There are business KPIs that you want to address. There is data that you can use, and there are technologies that you can process with. You can start from anywhere. You can say that, okay, I have a cool machine learning algorithm that could process the imagery, or I have a forecasting algorithm, but I don't have the data. But the most thing that I see is that people are starting from this area. That, okay, I need some kind of technology because I heard that it's very sexy, and they don't know why. And they neglect to connect it to some business KPIs. I want to achieve something. I want to use the data on my business meeting, or on my floor, or in my marketing strategy, or suggesting some solutions to my salespeople that what should they provide. So having all three is very important to start a project, or in every step of the project. Thank you very much.